Chapter 4 talks about pictures of data and how we can make those pictures. So we first need to identify the types of variables that we're going to study. Now remember, a variable is what we're looking at, and what we look at might be in some form of a category, which is qualitative, or it might be a number, and that would be quantitative. Now we must be very careful with this. In qualitative data, they could be numbers such as your phone number, but when we take an average or try to do anything with this number, it has no meaning. Determine whether a quantitative variable is discrete or continuous. Easy way to determine if it's discrete is if you can count it. It's countable, where continuous is something that you measure. Don't think about something as continually changing. It's that at that moment in time, I counted the number of students on campus. I counted them, therefore it is discrete. If it was continuous, I might be measuring how far they traveled. Identify the types of displays. Well, when we have qualitative data, it's like the M&M lab homework that you had in Chapter 4. Qualitative, you do a bar and a pie. Bar, remember, it needs to be, the bars are the same width. The height is telling me how often that happened. A pie is that circle when we deal with a percent. Quantitative or numerical is going to be done in that frequency or dot plot, which is that number line where we put X's. It might be in a histogram. And histogram, again, kind of looks like a bar, but we have these little bins, and we're placing items in there, and it works for continuous data. And then we have a stem and leaf plot. And we like stem and leaf because we can actually see our data and see the distribution. Stem and leaf is used for data that's more spread out than a frequency, but kind of the same idea of seeing your data and looking at the distribution. And that brings us to the distributions that we need to know. We'll be focusing a lot on the symmetric distribution for the rest of the course after this midterm. In a symmetric distribution, we say it is symmetric because all the measures of center fit here. The mean, the median, and the mode. Skewed right. Skewed right is a distribution where the tail is on the right. So it peaks and then the tail. That's not why it's considered to be skewed right. The reason is, if this is my median, the mean is pulled to the right. And why is it pulled to the right? Because of a few large, very large values. Pull it and make it larger than it should be. This often happens with salaries. So we want to make sure when we read something, did they take the mean or the median? Because when we take the median, all those big and small values go away and don't get added to the entire whole, which we'll talk about in Chapter 5. Skewed left has the tail on the left.
Seniors that haven't had all students who've had
Skewed left is the tail, and then it comes down, and again the mean is to the left because of these very small values, pulling it down and making it smaller. And then uniform would be straight across. So we haven't visited much about the uniform distribution, and nor will we. Association is how are the variables associated. This would be a continual rise. Negative is a continued fall, and neither is here. So the faster I drive, the more gas I use. Faster and more gas, that would be a positive association. Independent would be the explanatory. And how can I remember that? It's with X. Dependent is your response, and it is with Y.